We're end up asking the same question.
Yeah, I still have my book on me right now.
So the volume, it says the volume of a segment of a circular graveloid
Yeah, that one.
with the radius r and height h is volume equals pi r squared h over 2.
Yes.
I'm gonna be so mad at you if you draw.
Approximate the percent change in the volume where the radius decreases by 1.5% and the height increases by 2.2%. All right. So what should you use here?
Differentials.
All right. So if you use differentials, how would you set that up?
dV is equal.
Yeah, dV equals
Let me write this
dr.
It's pi r h.
All right. So partial.
Yeah, and then dr.
Okay. So you did the partial of this with respect to r, so dr.
And I do the partial with respect to h.
Yeah. Plus 1/2 pi r squared dh. Cool. And then, but now, how do you incorporate those percentage changes?
Divide by v.
Exactly. Cool. I love it.
Percentage.
Because if the radius changes by, what do they say? 1.5%. It decreases by 1.5%. Well, you got to be careful. So this is the suggestion I have so far, is to use this. The radius decreases by 1.5%. We don't know what it was before. We do know the volume right now is this, right? If you do this, it'll tell you how much it changes by. If you knew exactly how much the radius changed by, what you can do here is, what was the radius before? R, good. Now if it decreases by 1.5%, how do you write that? New radius would be
1.5.
yeah, 98.5. So 0.985 R. Right? How are we doing? No, we didn't like that. If you decrease anything by 1.5%, what percentage of it is still there? So if the radius was R, what is it now? 98.5% of what it used to be. That's how much of it is left. Right? So you're decreasing the price of a shirt by 20%. Well, now it's 0.8x equals blah, because 80% of that price is still there. Okay. Now, how could you use this? Could you use it in here?
No, you need to use it to find dr, right?
Yeah, well, now, you could do it if you did linear approximation with this, because then you could do r minus this, and you have everything in terms of r. We don't know what r is. In fact, we don't even know, even if we knew exactly how much r changed by, it's still going to be some expression with r in it. We don't know what r is, right? So, if we use this expression, do we know where to plug stuff? Not necessarily. I mean, what would the linear approximation of this look like? Because I know where you're coming from. You're thinking that if you divide it by dV, then maybe you could put the percentage in there. But that percentage is based on what R used to be, not on the total volume.
If we divide by v, this side is going to be dv over v. And then in here, v is equal 1/2 pi r h squared. So if you divide that, you will be left with dr over r. And that's the 1.5%. That's negative.
All right, so if you divide on this side by V,
Yeah, no, that's why v is equal 1/2.
and you can divide V is equal to this, so you can divide by this. And then what's dr over r?
And that's 2 times
And you have an extra
dr.
r there, right? So you have r times r.
Yeah, so dr over
And one of the r's cancels out.
and then 2 is flipped.
And then what's dr over r?
But
And you are
but dr will have an r in it.
The dr over r is 1.5%.
is 1.5%. Roughly, yeah. All right, but you could do, personally I would have done linear approximation, but this would work also. You're trying to force in there what this percentage would really relate to, what the expression would look like for this percentage. And the expression would really be delta R over R, right? That's the percentage change, is how much it changed by divided by what it was. So we're using the dr to kind of step in for that, right? It's really the same thing either way, but I just wouldn't set it up like that. But that'll work too. Yeah.
How would you set it up as a linear approximation? You would pi RH multiplied by R minus R.
Which is delta R. And then you can basically do the same thing you just did. Yeah. Yeah, but this will work too. I mean, they're really almost the same thing anyway. It's just that this is infinitesimally small steps, whereas the delta allows for cruder large steps. And actually the 1.5% change could be a, well actually it is a kind of large step. Okay, is everybody kind of with me on this? What would the, well, this will work too. I mean, if you guys understand this will work. You can do a very similar thing with linear approximation. The weird part about this problem is they don't tell me exactly how much it changes by. They give me a percentage change. So in some way I've got to incorporate that percent, right? That percent change, I've got to incorporate that. In fact, what do they ask for here? Yeah, exactly. So they ask for the percent change in volume. So what I would do, personally, what would the linear approximation look like for this? Wouldn't it look basically the same?
So you need your VR, right?
So the linear approximation to the volume would be Vx, x, well, let's just call it what they are. Vr, r minus r0, plus Vh, h minus h0, which is really what we have here, just with no delta, with d's, right? And then what do you have? Where am I going with this? Oh, and then you got your VRs here. There's my delta R plus your VH, delta H. And then you can figure out the change in V using that. And of course, if they want a percent change, the whole key here is they want a percent change in volume. So then you do like you did here, you divide by what the volume was.
So it's exactly the same reason.
It's exactly the same. It's just different symbols. Normally when you take a large step, you use delta. When you take a smaller step, or you're going to eventually let it go to 0, you use D.
So the delta R will be 0.985?
Well,
Is that what you calculated?
here, this will be, what I was saying earlier, this will be R minus, this will be the 0.85 R. Right? Or not 0.85, I'm thinking 0.95, yeah. Cool. But they'll end up in the same place, is what I am eventually trying to say. They'll end up in the same place, yeah?
Is that supposed to be delta R or the gradient of R? Isn't that the upside down one? The gradient?
Yeah.
I just got confused for a
My
second.
bad. Yeah, maybe careful.
Look at symbols.
I'm thinking ahead to other things, yeah. Okay. So it should be Greek letter delta, not gradient symbol.
Do you can like kind of work it out, please?
Well, either way you do it, it's going to come out the same way.
Well, like for your age, like.
What do you get here? You get 0.985 pi r squared h plus, what do I get here? This, what did it say the h changed by? 2.2% increase?
0.978.
No, careful, increase.
Oh, so it's
1.022, I think it is. Yeah.
Wait, how'd you get that again?
Because they told me it increased by 2.2%. So now it's 100 plus 2.2%, 1.022. Plus 1/2 pi r squared, 1.022 h. That's my change in my volume. And then divide by what the volume was.
Did somebody actually do this problem?
I got negative 0.985 0.008.
What's your answer?
Negative point.
Because now if you divide by
0.008.
v, you divide by 1/2 pi r squared h, 1/2 pi r squared h, bam, 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 times 2, right? Whatever the hell that is. 1.97, maybe?
Yeah.
Thank you. Plus the 1, bam, 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 plus 1.022. 2.992? Okay. Not percent, but then that would be almost 300% change, right? Or what would it be? Let's see if I'm talking right. Yeah, it would increase by. Does that make sense? Let me see.
What?
2.
Because you have the 1.022 H.
Mm-hmm. So delta V over V, delta V over V equals that.
And then you want percent change, right? So you just have to multiply by 100.
Yeah, that seems excessive. Right? How would you
They're
actually,
asking for the-
how would you check this? Believe it or not, you can check this. You just give yourself an R and an H, you see what the volume is, you change it by how much they say to change it by, and you calculate the new V. And then see your percentage change there, right? That's the way you can check this. So if I said, you know, R is 10, H is 20, then the volume would be 1/2 pi 10 squared 20. So you get 1,000 pi. Right? So now if I change R change, you can spell change, Jeff. Change. So R was supposed to decrease by 1.5%. 1.5% of 10 is whatever the hell it is, 0.15. I think it's 1.15, right? And then 1.5%. I'm sorry, 2.2%, right? Increase on 20. So 2.2% of 20 is 0.22 to 0.44, I think, right? Somebody help me think.
24.4.
Is it 4.4? So 2.2% of 20 should be
4.4.
22 times 2, 0.44, yeah. Oh, cool.
22%. And you get 24.4.
Yeah, 2.2% of 20 should be,
Oh, it's just 2.2%.
yeah.
That's right.
So now you can figure out what the new volume is. Pi. Oh, you already did pi.
Yeah.
Alright. So it'll be whatever the hell you get there when you put all that stuff in.
That's correct. So initially it was 1,000 by 9.78%.
What'd you get for this?
He's calculating.
It was 191.575.
I'm kind of curious as to like how it works out.
So it should be about 8.5 out of 1,000, because the pi's cancel out when you do this. The delta V is negative 8.5, so it should be 9% change. Not sure where. Something going on over there.
So I got like a 0.08 over here, like a negative 0.08.
Oh, cool.
That's what I got.
Oh, so where did I screw up?
That's why I'm so confused as to how you got 2.992.
where did I, let's see, what happened?
I did it the other way though.
Oh, this one.
Yeah.
Okay, okay. They should work out the same way.
Speak up.
Jay,
Yes.
we have to plug in DH, not the new radius and not the new height. We should plug in DH and DR instead of R2 and H2.
Yeah, so you need like an initial point and then
Where's that? Where's that? Where's that?
changing to.
Here's for DH, you plug in 1.022. We should make H2 minus H1. So we should plug in the rate of change, not the new height. And the
Oh, I know what I did.
So just negative 1.5.
I know what I did. So what are you saying now? I'm sorry. I think I know what I did.
which delta H is equal to H2 minus H1, right? Delta H equal H2 minus H1.
Yeah. So I put in there this, what I should have put in there actually
Yeah, but we plug-
0.015 because,
exactly,
Yeah, yeah.
which is the rate of change. And
Gotcha.
we plug in
well, because if you do H minus HO, original H is H, the new H would be 1.022H.
Exactly.
So
And
when
we
you
should
subtract them,
subtract.
you're left with the 0.022H.
Exactly.
Okay. Does everybody understand that? Sort of? So again,
Is that supposed to be negative?
delta R is R minus R naught. Initially it's R, right? What is it after the change? So it's like R minus 0.985 R. So it actually comes out to be 0.015 R. So I put a 0.985 in there. I should have put the 0.015 in there.
So instead of
And it should be negative because
Negative, yeah.
it's increasing.
Yeah, that's what I was trying to say.
Cool. And then over there for the H, the same thing, except that's increasing, so it should be 0.022H. Yeah. Cool. All right. But the idea is there, and the idea is the same for both of them. Cool.
Me, because he's a little good.
All right.
What do you get?
Like a negative 0.08.
Alright, you get 0.02.
Okay, yeah. I don't have
So
that.
from what we did up here, though, I think it should be roughly 8 point something percent, right? So, or 0.8 something percent.
Like 0.08 or 0.008, so like that.
Yeah, and then when you make it a percentage, it'd be 0.8.
Oh, yeah.
Yeah. Because that's what we did. We actually plugged numbers in just to see what it actually did.
Mhm.
Because this is regardless of, there you go. What R and H start off as. So you should be able to pick whatever you want to. And it should come out to the same thing you get when you do it with any R and H.
Okay.
All right. That was a good one to start off with.
Oh yeah, totally.
Any other questions that we can mess up on?
Number 30? I did. I don't have it with me right now. I forgot my folder at home. I just remembered this problem because I hated it.
And this problem, I mean, so I really hate myself for making that mistake. I didn't want to make it seem like it was harder than it really was. That was a very simple mistake for me to make, so too bad for me. But it is just the change in what it was and what it is now. It is now 98.5% of what it used to be. So the change should have been that directly that percentage. This one went down, that one went up. So this should have been just 0.022H there. All right, that makes much more sense than 300% change. That's kind of crazy. So yeah, now you'll get negative whatever, negative 0.03 plus 0.022 or something like that. Well, you get whatever you get when you plug all that in there. All right. I think last time, if most of you guys were here last time, we almost made it through all 12 days. What I really want to try to do, actually, very first thing I want to ask you is, I was working on trying to do an updated timeline homework sheet. I'm curious about your opinion of not having 4 tests, having 3.
Oh, you're gonna love it.
Now, if you think about it, there's a reason why you might want to keep
No,
it to
4.
Yeah, 4 and drop 1. That's a good idea.
About 4 and drop 1.
Yeah.
No. Either we need to one way or the other way. I like that 4 and drop 1. No. My intent for dropping down the number of tests was to be able to have some more time to catch up, but it was a change to the way that I established this class in the first place. I had to run it by you guys first. So if I were you, I'd want to keep 4, because that's one more grade to hold on to.
Yeah.
The worst class I ever took, the only grade we got was an oral final exam.
Oh.
That was exciting. So we didn't grade a damn thing until the day he set us in little rooms and then walked around and asked us physics questions and came back and attacked us. It was awesome. So we will keep it with 4. I'll work on the updated timeline and I'll have it for you next time. At the very least, we're going to definitely move the next test back. So test 3. November 16th. All right, so assimilate that information. All right, good. You guys are all assimilated. And right now, I think that this test will cover 12.8 to 13.5. But we'll see. And just to make this official, do you guys notice on your outline, your homework sheet, how section... That was on the... Was that on the last session?
No, that was 12.6.
Well, there you go. But on your homework sheet, if you see how section 13.6, I think it is in blue. Is it 13.6 if you had your homework sheet?
Yeah.
Yes.
That blue meant that it was going to be possibly extra credit, which it will be. Yeah. And do you see those sections under chapter 14 that say TBA for the homework?
Yeah.
The announcement now is we will not be doing that.
Wonder why.
Those were optional from the beginning for me. They're not really part of the curriculum, but they are optional parts that you can put in if you have time. We obviously don't have time, so we'll just.
Oh gosh darn it!
I know these things happen. Sorry. So we was bummed out.
Yeah.
All right, so just to go back over the main points from last time.
So we're moving towards 12.8 again.
Very quickly. And 12.8 is a really good place for you guys to take an example from the book and really notice the steps that they go through. I think I try to show you a few things to make some of the work a little easier. But let's run through an example from 12.8 and then we're going to go into 12.9. All right, perfect. So let's look at this here. Yeah. This is number 19. Critical points, I love it. So this one says, find the critical points and then test them using the second derivative test. Right?
You need S the X and S the Y.
I love it. So it's very analogous to what we did in Calc 1 and sometimes in Calc 2. You have to find the derivatives. In this case, you've got to find the derivatives in each of those directions, since they have such a larger dimensional thing to look at. What is fx?
4x to the third minus 4.
4y. I like it. 4y. Cool.
4y, sorry.
That's right. And then what's fy?
4y minus 4x.
I love it. Cool. And what do you want to do with each of those? Set equal to 0. So as somebody already noticed, this one leads to y equals x. And this one leads to
X or Y equal X here.
all right, cool. then how do you solve that? It's not that bad, right? It's like one of the most awesome ones you can get. Substitution, right? You got so realize that when you get fx, fy, you are getting a system of equations that you must solve between the two of those. So if you put y equal to x here, you get x cubed minus x equals 0. We're going to solve this. Don't make the simple mistake of dividing and losing an answer, right?
Wait, what?
What happened? So,
Oh, okay, never mind.
using this here,
Yeah.
X is 0.
and then you get x. Oh, we don't there.
0 and possibly.
I feel like I should give like a factoring quiz, because factoring is the thing that always pops up and just kills people out of nowhere, right? I love it when I had a Calc 2 student come up and be angry at me because I gave them something with a cubic in it. It was a grouping problem. Well, just go away from it. But I got over it. So you must know how to factor, or else you're screwed in general. What do I get here for x then? And then the really nice thing is y must equal x. So the points I get then are 0, 0, 1, 1, negative 1. Oops. Yeah, negative. Okay, so far so good?
Yeah.
Alright, so that was really just a system of equations. Don't let the factoring freak you out. Get one, put it in the other one. It's not that bad. So those are my critical points. Now, who remembers the setup for the second derivative test?
It's D, well, D, A, B is equal to f of x.
Yeah, it's really not that hard to remember, right? Just multiply the likes and then subtract. XX is like YY, they both have 2 letters, and then XY, XY, there you go, put those together. It's not that bad to remember. So you have to do that for each of the critical points that we found. So if I really wanted to be complete, like somebody said, you have to evaluate it at each of the points. Right. So go ahead and do that. So you're going to have to first, of course, get your second derivatives. And start plugging and checking.
Need it.
Who doesn't?
Alright, so let's see now. fxx,
Oh, x squared.
I like it. fyy,
4.
4, that kicks ass. fxy,
-4.
so either way you do it, if you do this with respect to y, you get -4. This with respect to x, you get -4. Those are cool because the fxx, fyy will always be -16 because of the fact that no matter what point you put, you evaluate these at, these are always the same. Right? Isn't that cool? So this will be, for any point we do, it'll be -16 minus something. So at every single point we do, D is going to be what?
Wouldn't it be plus?
I'm sorry, wait, I'm doing something.
Yeah.
Oh, yeah.
-16.
Those are my fxx.
So it's 48.
I was trying to make it too easy. What's fxx? Alright, so here we go. fxx at 0, 0 is 0. So then this will be 0 minus something. I really don't even care what it is, but it is -4. This one will be, D at 0, 0 is going to be,
-16.
Positive?
I like it,
What?
right? It's going to be negative,
16.
it's going to be squared, so it's going to be 0 minus I don't care. This is going to be less than 0, right?
Yeah.
So I know it's 16, but it's -16, so it's got to be less than 0.
So it's,
17.
And at 1, 1, this will be 12. So then I get 48 minus 16. That's always going to be minus 16. And that's going to be greater than 0. And at -1, -1, this will be again positive times 4, it's always 4, and it'll be the same thing again, right? So -1, -1, D is going to be greater than 0 again. Okay. And I don't care what the number is, I care what the sign is, right? So that you just go as straight as you can to get the sign of the answer. I don't care what the number is. I just want to know the sign of the answer is. Which one of these is definitely known? Right over the page.
0, 0.
And why is that?
It's the saddle point.
Because the only one that you have to worry about checking out the fxx is if it's greater than 0. If it's less than 0, it's got to be saddle point. So there's got to be a saddle point here. Now these two, D is greater than 0, so then it is exactly like it used to be in Calc 1. It all depends on the concavity then, and that you look at fxx to determine. And fxx is always going to be positive, and in fact, for that matter, fyy is always positive, right? At least when it's not equal to 0, this will be positive. So in both of these cases, then it's concave up, then those would both be minimums. I love it. This will be a minimum, and this will be a minimum. Cool. And I'm trying, I didn't see how it came out here. It's nifty. All the points are on there. It's neat. Almost. 0, 0. That's not easy to see that. Oh well. I try to go to Wolfram Alpha. It's not the easiest thing in the world to see. It's just really a kind of a plate, just a curve. You get kind of spoiled with the book that I can turn the picture around. Wolfram Alpha, I can't turn the picture around so I can see it better. But just to show you what it looks like. And this isn't that long of a process, really. You should expect it to be longer than it was before, because now I have all these other directions that I have to take into account. And that's really what that D tries to do. It tries to take into account the new things that could happen. So I can make this
this a little easier to see. No, it didn't like that at all, did it?
All right. So we can at least see like at 1, 1. So here's 1, 1 over here. And there's -1, -1 over there. We found out that those are minimums, and that does kind of make sense. Even though you can't really see this too well, it does curve up at the ends. You see how it's curving up at the end? So it does seem that if there's any minimums, they should occur in the middle there somewhere. Can you at least see that? It's not the best picture to work with. It's curving up at the ends. See that? Curving up.
So is it curving this way or is it curving this way?
Well, we're looking at it from. That's a good question. Actually. I assumed it was that one, but now you made it stick to my head. Let's see. If we compare it to this, we can't see far enough over here.
But it does go.
It does look like it's this way. Yeah. Yeah. So it's going up. So it does make sense that the minimum should occur somewhere in the middle here, right? Mm-hmm. And this actually, the darker it is, the lower it is. It's sort of like a better series of level curves. It's more like a topographical map, right? Contour plot, which is topographical map. So you can see it only gets dark at -1. You can see down here -1 and 1, 1. So those are my two minimums. And then you can see right in the middle is 0, 0. This, at least on this plot, we can see what's going on. If I go in this direction or that direction, it gets lower. I'm getting into dark area, right? If I go that way or that way, it's getting lighter. I'm going into higher area. So that's exactly what a saddle point is. I go lower this way and I go higher that way. That's a saddle point. Right in the middle. Can't see it too well on the 3D plot, but here, if you know what these colors mean, it makes sense why that's a saddle point. Is what I'm hoping. So if I'm you, this is not the best picture in the world, but it's definitely better than you can get in most places. If I'm doing this homework, you could really kind of quickly double check your answers. This plot definitely is a good one to see. You can double check what you get and see if it makes sense with what you see. Right? Especially because Evil Jeff gave you even problems to work for homework.
Evo. Pull this up for later. Where is it? There's. If you pay a lot of money.
If I pay money.
Yes. All right, we'll do that later.
Okay. So section 12A normally is, it's kind of nice because it's very definite. As long as you know the process you have to go through. Derivatives are relatively easy. Even partial derivatives are relatively easy, even though sometimes we can't say it. So this whole process, as long as you remember how to work this out, it's very simple to tell what's going on, right? And on a test, I might give you a problem with a lot of interesting critical points, but I'll give you a nice printout of what it looks like, so you can kind of double check, make sure it makes sense, right? All right. Okay. So one little thing, I think the very last thing I did, remind me if this is true, did we do a problem?
You were finding boundaries.
Thanks, dude, that helps. I was finding,
Your red was on the board.
You're using
thanks.
with a marker.
You're talking about that.
Yeah.
All right.
X squared plus Y squared is 4.
Oh, yeah, good. So I had a function like this.
Where's that?
I know.
started this one, I think we did the critical points and all that, right?
No, we
Remember
got to,
the-
we got to the point where you had it.
I remember.
It's like a-
Looking at the boundary.
Yeah.
Looking at the boundary, right?
Yes.
We did the critical points. Remember, this problem was the one that says find the absolute max and min. So that's the one in 2 dimensions. In an xy plane, you would check the endpoints versus the critical points. And all we care about then is what's the actual value. And the highest value is the absolute max, and the lowest value is the absolute min. Those are the kind that are really nice. Right? No extra test is needed. I don't have to do the big D thing. Just look at the values. The problem, though, is the endpoints don't really apply here. Because now I've got more dimensions. I don't just have x, one direction where it has endpoints. I have x, y. So now my endpoints are going to be the boundary of my region. Thankfully, in this case, we have a very nice region. We have a little circle. Yeah. So my boundary is this equation here. And I think the very last thing I was trying to get up here and then ran out of time was, how do you use this information along with your function to see what the hell's going on? Seems to be a good question, right? So, using this information, what could I put in here? I think this is the very last thing I did. This would then be 4. Y would now be
The square plus.
that guy, right? I like it.
Exactly.
I think I'll, in interest of time, I'll just jump to the conclusion here. So everything is written in terms of x, so I actually can do that. Everything's in terms of x now. So finding the max and the min on the boundary is now just a one-dimensional problem. Thank God, I can even write my f prime down here and know what the hell it means. Holy shit. So just to jump to the answer for f prime, you get -2, give or take 2x over this business here. Right, because this will be a -1/2 power. You'll have a chain rule to be careful about. It was supposed to be x squared. I'm thinking ahead. There.
So how do you know, like, that's the procedure you need to take, like, to say, I need to do the absolute maximum and minimum? Like, because they give you the setup, like, the real
To
one?
do the absolute max and min, you do the critical points as always. But you don't really have to do the D thing. You just have to find the values at those points.
Right, but
Keep track of those. Then you have to look at the endpoints, which in this case is the boundary of my region, which thankfully is just a circle here. I have to use those. I have to use points that must sit on this. So I might as well, then what's x squared plus y squared have to be? I don't care what points I pick. It's got to be 4. Because that's the definition there, right? And y can be replaced with what it is in terms of x, right? Because y is not free to be anything now, right? So now I have kind of taken it down to a one-dimensional problem. And again, just to remind you guys, this is different from the way the book does it. The book rewrites it in theta notation, so it's, which is a different way to do it. And then this guy, yeah, set it equal to 0. And eventually, I mean, you're going to get, add the 2 over, multiply this guy up, square both sides, right? You guys can attack that problem, not that bad. And you would end up at x equal to plus or minus radical 2. Which is the same thing the book is. Now the funny thing is, and the thing I don't want you to lose faith with, because the way the book did this problem is not the way you can do every problem like this. This is the way you can do every problem like this. The book chose a problem that, ooh, it's nice, yay. And I'm not really coming down the book, because they don't want to get to anything too much more difficult. But it's going to help us when we get to the next section. The next section, we're going to do a procedure that will make this easier. Because the problem with this, I got both my answers, but in general, I have to do this whole thing over again, solving for x. And then do f of y and do that. Otherwise, I might lose some answers. You guys kind of with me? Here, I just chose to go everything in terms of x. I've got to do the whole thing again in terms of y to really have this be complete. Right? That's the idea. Now, I mean, if I did all that, I actually would end up with just the y's that go with these anyway. Let's be honest. That's why I really don't have to do that, but I don't know that. I'd end up with y equal to, I think it's radical 2 still again.
It's like you just plug your x into your y function.
But you gotta be careful. The problem is, in this case, this one thing here catches all the answers. That's a coincidence, right? In fact, we'll do another one at the beginning. In the next section, we'll do it the old way, and then we'll do it the new, quicker way. Right?
Wait, so you plugged in radical 2 in for which one? The original?
What you would do right here is you would plug radical 2, of course, into the function and see what you get for y.
So into the original, okay.
Yeah. Anytime you want to complete a point, you got to plug it back into the f. Cool. Right? Of course, if I plug this into here, it's going to become on 0, because that's what I set it to do. And over here, what I'm saying is, you would write the equation like this: 4 minus twice plus or minus square root of 4 minus y squared plus 2y plus 5, and then go from there. Do everything in terms of y now. Okay, maybe. So then I get my critical points. My critical points are root 2, and negative root 2, I think. And now all I gotta do, and not my critical points, I'm sorry, the locations on the boundary that are maxes and mins. So then you plug those in, you plug in the critical points we got last time, and just see which one gives you the highest output and see which one gives you the lowest output from your function. The highest is the max, absolute max, the lowest is the absolute min. I really like the picture on page 859, which goes along with this problem. Let's see if they have it up here. Someday. There we go. Arr. There we go. Which one is it? Here it is. It's not as nice as, that's funny, it's not as nice as in the book. Rawr. Oh, I see, there it is. Oh, that's going to make me sick. This is page 859 at the bottom of the page. It's actually better than the book. I can't get that thing to turn around. See the 1 point, the highest red dot there? That's the absolute max on that circular region, right? That's the highest output for any point that's in or on that circle. So that occurred on the boundary. So one of these two is going to come out to be the absolute max. The critical points we found on the inside, one of them was, of course, at the very bottom here. And that's going to end up being the absolute min. That occurred for a point that was inside the circle. So the whole thing with absolute max is just like in calculus. That can occur inside your region, or they can occur at the end points, which now is the boundary points for us in multivariable calculus. Cool. Okay. So
how do you know it's not going to be like square root of 2 and then a negative square root of 2?
Well, when you plug in radical 2 into the function.
Oh, okay.
Yeah,
okay.
It'll kind of tell you what it is.
Can we find some of the answers for the even homework on Kramster?
I never actually used Kramster. I have no idea what it was.
Even ones.
You have to pay for the even ones, it says. Yeah.
Oh.
Anytime you want to come by my office and double check some work, that is not a problem.
Or even on Last Study Center, they have a solutions manual.
They have an instructor solutions manual for the tutors to use that you can double check it there too.
Yeah.
That always makes tutoring a little easier when you have a nice fallback. Okay.
Alright, Jeff. So these are the 2 points of absolute maximum.
These are the points on my boundary. They're the largest and smallest points on the boundary.
But you don't know which one's which.
Yeah, exactly.
And then what was the number 3 that we got? With the initial
And then last time we did the critical points, and that's what we did last time, and I can't remember what we got for critical points.
We got a 1 negative point.
1 negative 1?
Yeah.
And that was it?
Yeah.
So you plug in 1 negative 1 into here, you plug in radical 2 into here, you plug in negative radical 2 into here, and you see which one's the biggest number, that's the max. Which is the smallest number, that's the min. That's why I don't need the D thing. I don't need D because I can just see the highest and lowest value and I'm done. Now why can't I do that in general then? Why can't I just look at the highest and lowest value and stop there in general? Because of course, in general I'm curious about local maxes and mins. This guy would kind of hide that guy. He's bigger, so I would maybe not even pick him up. But this is constrained. This is saying not going on forever. It can only be from here to here. Then I am just worried about, okay, what's the highest thing I see and what's the lowest thing I see? It could occur on the inside or it could occur on the endpoints or the boundary, like we see now. Okay, cool. All right. Cool. That's what I remember from Calc 1 is once you got to absolute maxes and mins, it was so much nicer than all the second derivative tests and all that kind of stuff. You don't need them. Just plug the things in and see which one's biggest, see which one's smallest.
So in here, if we had a question like that, pretty much can we just put it in a calculator, solve for x, and find that point? Or we have to do it all out?
Well, you have to do the derivative stuff. And what you do from here to here, I almost don't care. You should be able to solve this by hand. But
I mean, what if it's like really big, complicated?
Then you just plug in the calculator. Sure. Okay. Sorry. All right. Let's take a short break.
10 minutes.
5-minute break. You guys are good. 8. Come back at 35 after. 6-minute break.
7.5. We're high.
4 minutes.
Read yours slow, I read mine.
I don't know.
Sorry, this is actually an example in the book. Here, example.
Alright, that makes a lot of sense. I thought you were saying what happens if you can online?
Oh, yeah. It's the empty function, empty option. Something like that.
Okay.
Just my really horrible writing. Maybe we'll look at it if you want.
It ends up being your
Cool.
And then so from
This was given to us. So they tell me to find the answer maximum min for this function for the points that lie on this in this disk. So inside the disk we looked at the critical points. So for the same thing like way back when, they have to actually be in that region, and of course this is. If I get one that's 4.3, that's outside of the region. I can't use that. Okay, cool. So we got that, and then we have to look at the boundary.
Oh, okay.
okay.
So I need points that lie on this here. So that's what we use to rewrite this. X squared plus y squared then must equal 4 no matter what I use. Because x and y have to lie on this
My room is
circle.
coldest in the winter.
And so the circle is also this, so I can replace y with what it is and go from there. Yeah. Then I make it a nice one-dimensional derivative here.
Yeah, I can definitely put that.
But the trade-off is I have to do x way and I have to do it the y axis to make sure that I capture everything. So we'll do another hopefully quick example showing you that we have to do it both ways or else we miss something. And then I'll show you the quicker way to do it. That's what section will not.
It's the first reference, so we have 2 stories, and
well, you plug a root 2
there's
in.
the garage door, and then there's
You got root 2 there.
I'm sorry, where am I? Plug a root 2. In fact, what was it? It was supposed to be.
And so the screen's just laying there, and you can see it from the
Wait, so
screen.
he climbed up to the second story to get his house?
Yeah. It's the only open window.
But he can't manage to grab the screen before he goes inside.
That's my thought.
He's like, oh, okay.
So like, I'm just gonna throw this off and go in.
Don't worry, by the end of the weekend, I'll completely rescreen it and put a new
But
one
the
on.
thing, yeah, but those screens, they bend up.
Yeah, if you plug a radical
It
2.
won't
Yeah, you
fit
can pry
the
it off.
screen.
You have to pry
Yeah, they'll just be like a
into there,
corner
you
where
do get
yeah,
like a
shove
radical
something in there so no bugs go.
you get two
I
plus
used
y
to take the
equals
streets
4,
off
you
my
do get
windows
5
all
plus or
the time.
minus.
My mom used to get
Yeah.
so mad at me.
So it should be
It's like,
plus or minus
"Shut my
here.
window."
It actually should be plus or minus there.
And we have
Now what they did, doing it their way,
last thing I want to
they
do is like have my
eliminated one of those
and all of a
options.
sudden this
For us, it's like
Yeah.
2 more points
the last
separating
thing I
out
want.
function.
My mom was running one day.
But like I said though, if my region had been elliptical, converting to theta notation would not have been necessarily easy,
It's nighttime.
right?
You know, the trees are all set.
So that method they use is not general either. This is more general. I might get more options to check than I would have otherwise, but it's still quicker than it would be to try to figure out how to read it and use it.
Yeah, I've seen that. There's always this owl like outside my house, like you.
Yeah, root 2 plus or minus root 2, negative root 2,
I
plus or
can't
minus
hear it in my
root
room, but my mom said that.
2. It should be root 2, yeah.
Okay, we haven't had any pellets.
Which I think is almost,
Yeah, just always.
which is all
And then there's like a
ways
lake
to do it.
outside, so you can hear frogs.
And really, all these things.
It's like,
Yeah,
you
yeah.
know, like.
So I do get, the book had just the root 2, negative root 2, and the negative root 2, root 2. So their method kind of eliminated
Yeah, I hear the freeway by my house.
eliminated
My
the
window's
root 2.
open. Yeah, if my window's closed, it's really thick, so.
Like I really only have
it's
one
facing
extra
the street,
thing here, don't I?
right?
Yeah.
Root 2, root 2.
And so it's really loud.
Because this has
but
also got a
if
root
my
2, root 2.
fan's on, I
So it really
can't
just
hear
got
it.
one extra
And
answer.
if my window's closed, I can't hear it.
That was one of the things my parents liked about our new house is that it's like away from the freeway.
Yeah, but it's to the point where if my window's closed, like I can't sleep. It's too quiet. Yeah, I'm so used to it.
Okay.
I'm very happy with breaking through.
It's going by really fast.
Well, especially like the first half of the semester just went by like really quickly, but now it's
Still going by fast. It's not as fast. It always goes by fast once it's over.
okay. Now it's moving.